Hi, in this video, we're going to take a look at configuring IPv6 static routes. Okay, so the first thing we need to do is use the global configuration command IPv6 unicast routing. This is required for the router to forward any IPv6 transit packets and also to participate in static but definitely dynamic IPv6 routing. I kind of hesitate on static because you can do static routes in the router as long as they're not transit packets. Anyway, let's just say use IPv6 unicast routing command that actually turns the router into an IPv6 router. Okay, and a side note, it also what it will also do is how the router will begin sending out router advertisements on any of its Ethernet interfaces. Okay, but back to static routing and IPv6. Use this command. That's the first thing we need to do. All right, so here I do show IPv6 route on R1, and we see that it has two directly connected networks. Looks good. I could do the same thing on R2. Directly connected networks. Notice no static routes, no dynamic routes, no routes learned dynamically. And here on R3, everybody only knows about their directly connected networks. Okay, so we ping an directly connected, an address on a directly connected interface. In this case, we are pinging the 2001 DB8 ACAD 4:2. So that is an address on R1's directly connected interface. And because that link is up between R1 and R2, the ping succeeds. The echo request goes out, the echo reply comes back. Okay, you might also at times see the ping IPv6 command in iOS. That's when you really don't need to use that. Just using the ping command, and if it sees an IPv4 address, of course, it's going to send it out as IPv4. If it's going to sees an IPv6, sees an IPv6 address, it's going to send it out as an IPv6 packet. If it sees an IPv4 address, it's going to send it out as an IPv4 packet. All right, so again, talked about this when in a previous video when I discussed configuring IPv4 static routes, but we have next hop static routes, most common, directly attached static routes, exit interface only, don't use this, and fully specified static route. Okay, so look at my video on directly attached static routes in configuring IPv4 static routes, and I talk about why you don't want to do this. All right. So in most commands on iOS, either configuration commands or show commands, whatever they might be, IP means IPv4. And when we're talking IPv6, she says IPv6. Okay. So it's very similar to configuring an IPv4 static route. Okay, let's take a look at the next hop static routes first. Okay, we just say IPv6 route, the remote prefix and prefix length. So this is the prefix and prefix length of the remote networks. Okay, notice there's no space here between this. Okay, so the /64 is these first 64 bits, and then this double colon means the last 64 bits we don't care about. Kind of, this would be what we would think of as the network prefix or the network address, and then followed by the next hop IPv6 address. Pretty straightforward. Okay, we do the same in router R2. Okay, and we can do a show IPv6 route on R2, and we see there's the static routes on R2, the IPv6 static routes. We do the same thing on R3. Okay, so here we have 3 IPv6 static routes, and we verify it using the show IPv6 route command to display the IPv6 routing table. Okay. So a fully specified static route is used when one of two cases. When Cisco Express forwarding is disabled. Again, look at my video on configuring IPv4 static routes, and I talk about that. But CEF is enabled by default starting with iOS 12.2. Or if the exit interface is a link local address. Okay. All right, let's talk about this. First of all, what is a link local address? In IPv6, link local addresses are used to communicate with other devices on the link. They're not routable off the link. Okay. These addresses only have to be unique on the link because they're not routable. Okay, we'll see that in a moment, but a router could have the same link local address on two different interfaces, as long as it's unique on that link. Okay, not included in the IPv6 routing table. Link local addresses are not included because they're not routable. Okay, and for an IPv6 device to be an IPv6 device, it must have at least a link local address. It doesn't need what we call a global unicast address. Okay, that's what we think of as the typical public IPv6 address. So link local addresses are used by hosts to communicate to the IPv6 network before it has its global unicast address, because devices give themselves, most devices, Windows, Linux, Mac OS, routers such as Cisco IOS, they give themselves their own link local IPv6 address. That way, when they boot up, they say, hey, I can talk to anybody on my network using my IPv6 link local address. Pretty cool. They exchange, routers use link local addresses as the default gateway address. So that's the address advertised in something we call the router advertisement to tell devices on that link, hey, I'm your way out of here. Here's my link local address. And adjacent routers, routers use their link local addresses in many, if not most, all of dynamic routing protocol messages. Okay, so I mentioned that routers and other devices, but in this case, let's take a look at a Cisco router, creates its link local address automatically. Okay, so Cisco IOS, what it uses is a process called EUI64 to create its link local addresses. So basically it uses the MAC address of, let's say here we got gig 00 interface. It will take the MAC address and it uses the EUI64 process. What that does is it inserts FFFE in the middle. That gives it a the extra 16 bits. So it goes from a 48-bit MAC address to a 64-bit interface ID, prefaced with FE80 and the rest of the 64 bits for that. And it actually flips the 7th bit. That's why this C gets flipped to an E. So because the 7th bit in that hexadecimal digit got flipped. Okay, but you may be thinking, hey, wait a minute, Rick. I see serial interfaces. They don't have a MAC address. That's okay. They just use any of the gigabit Ethernet interfaces MAC addresses. Wait a minute. I notice here my gig 00 and my serial 000 have the same link local address then. That's fine. Okay, remember link local addresses only have to be unique on the link. So what does this have to do with static routing, Rick? Let's take a look. Okay, so first I've configured link local addresses on R1 and R2. Let's just remind ourselves how to do that. Okay, we have to say link local after it. Now notice R1 is going to get the same link local address on both of its interfaces. Okay, same thing with R2, but these addresses only have to be unique on the link. Okay, so R1 and R2 have two different link local addresses on this link. Okay, let's get, because here we're doing a static configuration. This is always better. For routers, you'll want to do static configurations of your link local addresses. So it's something we can recognize. I don't want to know what the FE80 double colon and then all that long, all those hexadecimal digits. This I can remember. All right. So let's get back to this. What if I wanted to do a static IPv6 route, but I want to use the next hop a link local address. Well, iOS is going to tell me, hey, you need to specify the exit interface, the egress interface, because this next hop address, FE80:2, could be out any of my links, because it only has to be unique on that link. So you have to specify the exit interface as well. Okay. Okay, configuring a default IPv6 static route. Okay, so the double colon here means all zeros. /0 prefix length. We're just telling it, hey, 0 bits need to match for this to be a match. Okay. All right, so configuring that, pretty straightforward. IPv6 /0 and the next hop IPv6 address. Verified in the routing table. Looks pretty good. Okay, let's go ahead, and if we've properly configured all the other routers, we should be able to ping our remote network address there. Okay, so if you want to learn more about floating static routes, and I talked about the static route that uses only an exit interface, which we shouldn't use, and also a discard route. Take a look at my configuring IPv4 static routes. The same concepts apply to IPv6. Okay. So I hope you saw how really easy this is, and how similar both IPv4 and IPv6 static routing is. All right. Look forward to some more videos on IPv6 and IPv4 static routing coming up soon.